RIKEN Center for Computational Science in the city of Kobe, Japan. It's a world-class facility for innovative computer science work. Housed in this building is the Supercomputer Fugaku. In June and again in November 2020, Fugaku was officially certified as the fastest in the world in 4 different computing benchmarks. The top 500, HPCG, HPL-AI, and Graph 500. Fugaku was the first to take first place in all 4 at once, showing the versatility of its outstanding performance. The engineering work on Fugaku began in earnest in 2014, taking 6 years to complete. The goal was to perform up to 100 times faster than the K computer on a range of applications.
I actually didn't think it would be that hard when we started it. And almost every year, another obstacle arose, and we would clear it. That's how it felt.
The first thing the developers worked on was designing the CPUs, which are the brains of a supercomputer. They used state-of-the-art 7-nanometer production to equip the CPU with 48 cores. That's 6 times as many as on the K computer. The CPUs also include a new built-in network interface called Tofu-D. And stacked high-bandwidth memory is on the same silicon die as the CPUs, greatly improving performance. The most important thing in development was co-design. In this approach, the hardware engineers repeatedly consult with the software engineers that will write applications for the completed supercomputer. Each team responds to the other's opinions and requests. More than 1,200 co-design meetings were held. These collaborations helped a range of user applications to perform up to 100 times more effectively. Careful attention was given to make the Fugaku extremely energy efficient. The CPUs have power control knobs to dynamically regulate power usage. And the power supply units were rearranged to reduce wasted electricity. The results are nearly 20 times as energy efficient as the K computer. The computer building's facilities have also been upgraded. Additional transformers were installed on the 2nd floor, and many heat exchangers were added to boost cooling capacity for the CPUs. The time required to assemble the Fugaku was shortened by automating processes and adding special assembly line equipment and image inspection devices. In May 2020, the last of the 432 racks arrived in Kobe. Around that time, Japan had declared a state of emergency in response to the COVID-19 pandemic. Before it was even fully assembled, the Japanese government asked RIKEN to use a scaled-down version of Fugaku in the fight against the coronavirus. One of the results was a program that models indoor environments to better understand how droplets move through the air when people talk or cough. They also examined mask usage and confirmed that masks are actually very effective. Fugaku has the potential to tell us even more about our world. In the basic sciences, for example, we hope to learn more about the origins of the universe. It could also accelerate drug discovery and new medical treatments that will help people live longer and healthier lives. It might better forecast weather and natural disasters, such as earthquakes and tsunamis, making people around the world safer. It could speed the development of energy-efficient technologies and the adoption of clean energy systems. And it may accelerate the introduction of new materials and innovative manufacturing processes, making industries more competitive. Fugaku can help us find solutions to problems in a wide range of fields, providing support for the ultra-informed Society 5.0 of tomorrow.
Well, we had set out to build Fugaku to be 100 times faster than K, which was like a moonshot goal. The objective was there, very clear, but there were many technical issues, but we had overcome every one of them to achieve the goal of building Fugaku, which is now not only the fastest, but probably the most useful supercomputer in the world.
Supercomputer Fugaku will make major contributions to the future of Japan and the world.